All right, so what we want to start off with is a basic definition. We're really going to look at two different definitions today, and that's going to be it. So let's start with, let's just say we took something like a to the 1/3 power, right? And this is a new idea, at least in this algebra class, to have a fraction as an exponent. We know that a to the first power is simply just a. We've done that all the time. But a to the 1/3 power, it's going to look like this, where we take this denominator of 3, and that's going to be the index of a radical. So this is actually telling us to take the cube root of a, right, where your denominator is actually what we call that index. So your denominator is the index of your radical, right, where this number is called the index, and this sign itself is the radical. Now, just for a vocab review, do you guys know what the vocab word for a is in this case? Not this would be a base right here, but when it's right here, do you know what that is called? Ryan?
The base.
No, unfortunately, that would be nice if we kept the same vocab. We don't. So this base here. What about right here? This almost never comes up, which makes sense why no one. Oh, you got a guess? You look like you have a guess. No, this is called the radicand. It's a funny word, and it rarely comes up, right? It doesn't hurt to know, but not like I'm going to ask you to define it or something on the test or anything. All right, so let's make this more general, right? So I gave you an actual number. If we took some base b and raised it to the 1/n power, that would tell us that we have the nth root of b, right? This is the general form of it. And a could be any number, right? N could be any number. Well, specifically though, n is going to be an integer, right? Obviously, it has to be like 1, 2, 3, 4, 5. It's not going to be a negative number. That won't make sense with an index here, right? So the first thing we want to do is we just want to get comfortable going from writing something as an exponent, like b to the 1/n, and turning it into a radical, or going the other way, taking a radical and turning it into an exponent, all right? So let's do this on our first example problem. So just go, if it's an exponent, write it as a radical. If it's a radical, write it as an exponent. Okay?
Fractions?
Ryan, you got an answer for us?
Yeah, a equals to, I don't know how to say it.
Yeah, so you're going to use a radical with an a here. And what's their index, right?
5.
Yeah. Here's how I want you guys to read this. We're going to say this is the 5th root of a. Right? So whatever that number is, right, that's going to be what root of a we're taking. So the next one, still take a volunteer. Phil?
7, 3, and 10.
All right. So then in part C, I gave you the 10th root of n. So then somebody turn this 1/10. Awesome. And then I gave you the 100th root of m. Patrick?
M to the 1/9 power.
There we go. Right? Just like that. So then let's take this idea and let's put numbers instead of variables here, and let's evaluate. So for this example, I want you to, even though I didn't tell you to, I want you to kind of get the practice of convert this to a radical and then write your answer, right? So change this to a radical, this to a radical, these two to radicals, and then evaluate them. So you should come up with a 1-number answer. And for starters, Will, can you rewrite 125 to the 1/3? What is this as a radical?
It's 3 and the square root of 125.
Yeah, the cube root or 3rd root of 125. Patrick, what is the cube root of 125?
5.
We should get a 5. All right. Jacob, can you rewrite 64 to the 1/2 for us?
64 to the how do you say that?
Well, in this case, you can just say it's either the 2nd root of or.
Second root to 64.
But if you think about the 2nd root, what's another word for that? We should call it out. It's a square root, right? So that when it's a 2, we actually don't even write it, but it actually is the same thing, so you can write it. It means the same thing. And then, Noah, what is the square root of 64?
8.
8. All right, Jake, can you rewrite just 36 to the 1/2 for us?
Yeah, that was 36.
Yeah. Square root of 36 in that case. And then, Haley, what about 64 to the 1/3?
The third root is 64.
There we go. And then, Nelson, what's the square root of 36?
That'd be 6.
James, what's the cube root of 64?
Is it 4?
And then, so we get an answer of 10. Awesome. So if your index is a 2, it's just simply taking a square root, right? So if your index is a 2, and you don't actually even need to write it, you can just do your square root sign, your radical, and that's it. Other index or indices you need to write. Yes?
Can the third root of the cube root of?
Yes. All right, so let's look at Sam's question. What if you change that numerator to something other than 1, right? So let's just look at the general case and then we'll look at a specific one. So let's say we took some base b and raised it to the m over n power. We already know that this is your index, right? N is still going to be your index, so that doesn't change. So n is your index. M is just a normal exponent, so this actually doesn't change what it means. So this is a normal exponent. So this is what it would look like in a radical form. We actually have two options. Okay, so we can write it in two different ways. The first one is you can say you have the nth root of b, and you raise this to the m power. And then the other one is you just move that m. So you could say you have the nth root of b to the m power. These are the same thing, right? And so it's up to you to decide which one you like to use better. And let's use all this, I'll pick a number like 27. And let's say that we had this. We have 27 to the 2 over 3 power. And let's evaluate it using both ways. And this will quickly tell us which one's better, because one is better than the other. So let's, just as we did here, let's rewrite it in both of these forms. So the 3, that's our index. The 2 is what our regular exponent. So the cube root of 27, and then that number squared. And then the other way would be the cube root of 27 squared. So just looking at these two, which is easier, the first or the second one?
Top.
I'd say the top one. What's the cube root of 27, everybody?
3.
So this becomes 3 squared. What's 3 squared? 9. Do you guys know what 27 squared is?
No.
I know. And so this one, this normally is not what you want to do, right? You get the exact same answer, but this is going to be almost every single time your better option, all right? So typically you want to take your root first, make the number smaller, and then raise it to a power, right? So treat the numerator, it's just a normal exponent. You're going to square something, you're going to cube something, whatever that is. And the denominator is, we're getting used to that being our index, taking that root. All right, so let's take this and do the same thing. I'll give you some numbers. And I want you guys to do the same thing we just did. So rewrite it as a radical. That's just to get you that practice. And then write your answer. Rewrite as a radical, then write your answer. All right. Hannah, can you rewrite this first one for 16 to the 3/4 becomes?
I said of 4 radical 16 in parentheses and then 3.
Yeah, the 4th root of 16 and all of that cubed. So then, let's see. Maura, what is the 4th root of 16? That's the square root of 16. So what number times itself 4 times gives you 16? 2. So we get 2 cubed, which is 8, right? So the index tells you how many times your number has to be multiplied by itself to get to this number, right? All right, part B. Eliza, can you rewrite this as a radical for us, please?
It's the third root of 27 to the 4th power.
All right. So then we want to take, Reinhardt, what's the cube root of 27?
3.
Yeah, and then we get 3 to the 4th power, which is the same thing as 9 squared. So we should get out an 81. All right. Lily, can you rewrite part C for us, please, as a radical?
It will be the square root of 81, and then that's in parentheses of over 3.
There we go. Square root of 81 cubed. All right, so what's the square root of 81, everybody? Okay, 9 cubed. Now, what's 9 squared? 81. So then just multiply by 9 again, and that actually works out really nicely to just be 729, right? 9 times 8 is 72, 9 times 1 is 9, so that one just works out pretty nicely. So one more type of problem to finish up today. Now, so everything that we just did today, right, at least in your mind, you're going to change it to radicals and evaluate, right? So these problems that I'm saying simplify, like in this case, you don't want to change this to a radical. This is actually a property of exponent problem, and so you don't really want to think about today's lesson that much, except for the fact of like, how could you evaluate or use what we just learned about a fourth root to maybe change that to an exponent, right? These two are property of exponent problems, and so you want everything to be written in exponents, and then use our properties. Like when you multiply powers of the same base, what do we do with the exponents? Add them. What about when we divide powers of the same base? And when you raise a power to a power, all right, thank you, Patrick. So with this first one, I would, at least in your head, but I would, as you get used to these problems, I would rewrite it like this. And then when you raise powers to a power, you multiply the exponents, right? So you end up with 1/4 times 4, which is 1, and 12 times 1/4, which is 3. Now another way that you can think about this is anytime you are taking a root and you have variables in here, you can simply divide your index into your exponents, right? Which is exactly what we talked about today, that whatever you're raising it to is your numerator, and the index is your denominator, right? So this is your regular exponent, that's your numerator. This is your denominator, so you can just simply divide them. So you should get x, y cubed. This one, as you simplify, right, in the numerator, you would multiply exponents, so x squared y to the first. And then in this case, you can either divide here, 5 goes into 5 once, or you can rewrite this as x to the 5th to the 1/5 power, right? And so you still get x to the first. And so then when you simplify, you just get x, y.